Hello everyone, I'm going to talk about Kafka today. The Kafka is an open source distributed event streaming platform engineered for high performance, scalability, and durability. It uses producer to send a message to topic and consumers to read them, with message being stored in the orders immutable partitioned across multiple broker. It is highly suitable for real-time data processing and synchronized message query in the system design. So why we need Kafka? Kafka to solve what kind of problem? So let's start from the motivating example here. So for example, there's a website, and the website is managing the football game, like different countries competing two different countries competing each other, and when the some of country just competing each other, and they want to change people and show the real data, the kind of like show the status of the every team. So this is the suppose here, or something got like a red flag, some kind of like just update the status. Now problem here is too many events in the queue, and the servers hosting the queue running out of the space. How could we do that? There's so many, right? So we have one solution is scale horizontal. So original we just one queue, and for now we have the two queue. So we need this one to consume before the sub below. So this problem. Now events for current now we want problem is another happens here. We want to this one in based on the order. Now events are not processing in the correct orders. I want to do this first, but maybe it will consume this first, so this is a problem. So how could we do that? Then we partition by the game, like by the this just like a China and the United States, right? This is all the status of the two countries, and this may be the France with other like Japan to competing. So every queue represents just the two country status. Okay, so and also for current now we just can website, right? Just to have one consumers can keep up with the rate of new events. If the current rate is very high, how could we do that, right? Now we come in here for the multiple consumers. There are so many updates, then multiple consumers can get those information and update in the website, something like that. But also it will encounter some problems here. Want to keep each sport separate. Like this is a basketball, and this is a football. So we can like this one is kind of like TV show, right? It is called like football TV show, and the consumer just want to get some information relative to the football. Then it will get information only from the football topic. And this is basketball TV show, and the basket TV show just only want the information relative to the basketball. So we can set this basketball consumer group just to consume the information from the basketball topics. So this is a way to solve this problem. So this is the idea about the Kafka to solve when we have so many information or event, and we want to get some real-time data and to consume it in the different consumers, right? So this is the event-driven architecture. Now we come here for the terminology about the Kafka. Kafka has the broker, the servers like a physical or virtual that is hold the queue. This is called broker. And partition, the queue, is an order, immutable sequence of messages that we append to like a log file. Each broker can have multiple partitions. This queue. And one of partition here. A topic, a logic group of partitions, and you push to and consume from the topic from Kafka. This is group and this is topic. Producer is event input. It's kind of like input output. So write message, write records to the topics, and the consumer is get or read message from the topic. So look under the hood. The message, the record, we have the head, key value, timestamp. And how could we add a record via this is common, right? So we can write this common in your terminal, then it will show up this thing. Also, you can integrate with the program language, and Kafka can offer a lot of language, some Java, JS. For here is JS. You can see here, initialize the Kafka clients. Here, right? Brokers. And initialize the producer, this producer. This is connected to the producer. And sending the message by the topic with the key. You can see my topic. And the message is key 1 value something here, key 2 something here, to sending the message. So this is a way how the Kafka's integrate with code. And the second way is Kafka assign the message to the correct topic, broker, and partition. Let's see, publish the message to the topic, right? And the partition key present. How could we know the producer send the right key? We have two options, right? We have the round robin or other logic. For here, it's kind of like hash it, then identify the broker for the partition. And then send a message to the broker, and broker append a message to the correct partition. So this is how the producer is doing here. Now let's see. And the message append to the partition via append only log file. For here we have like it's message A, message B, message C, message D, message E. So for the producer, we have the offset, right? So offset is it's kind of like 2-pointer index to point here. This is all current here. Producer I added here, and we got the kind of like index here, right? And then if the producer has more event or information or the data you want to add it, then we will add it here. So it's kind of like use the one pointer to check the index. And also same with the consumer, which is called like offset. Treat it as like an index. So we have the consumer. It will read the message from this index, this here, and stop here. And when the consumers want to know current now where I am, right? So then we have the consumer offset to checking. You current here, you already consumed the message C. Now we can start from the D. So this is purpose for the how the producer and the consumer track the message location. So consumers can read the message based on the offset, right? Here, you can see here like consumer consume the message from the Kafka by the offset, and the message delivered, right? And then keep reading, and when it's reading, when the consumer is reading, then it will send the commit offset. And the Kafka have, which is called like a consumer offset, it will store the offset and help a consumer to tracking of where you are reading now. Then after the finished reading, it's like this. Okay, this is Kafka. I think it is around here. Let me change. Yeah. And for the commit part, we have 3 options. The first is at most once, which means commit first, then consumers will just like commit like offset or current here, right? Current here commit A. I get the information, but I didn't consume. I commit first. So current here, it will store like message A, you already read it, you already consume. And you next star is from the message B. But this happens might be like consumer, if current here, consumer just got the message and the consumer just failed. And which means the consumer didn't really read the message A. It will make the information missing because this one is already tell me you already commit and you next start reading from the B, but actually message A, I didn't read it. I just failed and lost the message. So this is the situation for the first one. And the second one is consume first, then commit. So this is default one for in the Kafka. So this one can make sure consumer consume the message first, and when this message consumed, then it will commit. So which means like the current here consumer, maybe it will read the message several times. I didn't, right? You can update here. You didn't update here. I read it, but for here not update. Then I will reading it multiple times. But at least if I consume, I will send it to the update the offset. So this is happening here. And for here, and also the last one is also it's very tricky, the one which is called it's actually reading once, not lost the information and consume only once. So this is based on the Kafka like a string API or transaction producer or translate consumer to Unity configuration about that. And also which is called like item potent. That means like whatever, how many times you doing the operation, the final always same. The final result is always the same. So they are used that way to make sure exactly once. Okay, so let's see how can we read the records from the client code here. This is from the consumer side. Yeah, this is the common. And add the records from the Kafka based on the JS part. The first is initialize the Kafka client, right? Initialize the consumer and then connect to the consumer, subscribe to the topic, my topic, and then consume the message. Yeah, this is the way. And for this one is kind of like the whole picture about the Kafka. So we have the producer, and producer it will sending the message. Normally it will serialize this through the API, producer API. And then the message will based on the topic, you can see here, send it to the different brokers. Like topic A, it will send in multiple. This is kind of like a leader. This is called a leader one partition. And the rest of like follower or something is copy the information from the leader. So this is a very great thing in the Kafka. It's make sure the reliability. if the current here leader is done, and then it will pick up another follower as the leader. This way it can make sure the information will not lost, the message will not lost. So this is like a broker here. Because in the broker, like we can treat it as like a server, and in the server there's a multiple topic, and multiple topics you also have to duplicate lots of followers to duplicate the leader's information. So this is the Kafka cluster. And how could we pick up which one is leader is based on the zone keeper, select leader. That is another technology to handle the leader, which one is follower. But this one is kind of like the performance might be not pretty good. After the version of the Kafka, they used the k-raft to replace the zookeeper. Yeah, and when the consumer, you can see different topic, and it's where they serialize the information, and through the consumer API, it will get the information. It will pour. It's used like through the consumer API to pour the information. So this one is active to get the information from the Kafka. And this is the Kafka's look like. And let's see when to use the Kafka in an interview or something. So anytime you need a message queue, right? Processing can be done async, like YouTube transcode. For here, like and use Kafka transcode. And the second is the message process, like taking master, waiting the queue. It's more like event trigger. And another thing is called like decode. Producer and consumer, they can scan independently, like lead code, online judge, right? Primary, Kafka, worker, and so many things. It's more like just based on the event. You feeling that things can treat it as an event, you can also use the Kafka. And anytime you need a stream, need to process a lot of data in the real time, like add, click, aggregator, client, producer, Kafka, like this a stream, right? Flink database. This one is the stream of message need to processed by multiple consumers simultaneously. Messenger and Facebook leave comments. Kafka trigger something and then to return that. Why you should know? Why you should know about Kafka for deep dives interviews. Okay, scalability, right? So for scalability is right, you can see here video values S3 URL transcode smaller than the 1 MB per message. It's good. Okay. And 1 broker to the 1 TB data. Per second. Okay, so there's some constraint about the Kafka. The Kafka have some like which one? That in the tutorial. Yeah. How to scale, like more broker, choose a good partition key. How to handle a hot partition, we can remove the key, component key, add some like 1 to 10, right? Back pressure, slow down the producer. What about the fault tolerance and durability? For here, we can use the fault tolerance, right? We can use accuracy. We can set accuracy is equal to 1. Equals 1, which means equal to all, which means when sending the producer for the through the producer API, and sending the message to the different partitions, right? It will sending something, oh, current how I got your message. It will return back some response. And for all means all the whatever the lever and the follower, they all need to return the response, because I need to make sure the follower already updated the latest information. So this is the very, you have to strict to make sure the message is sync up is you need to wait more time. So normally it's just the setup for the leader who got the message. It will be okay. It's more balanced. So what happens when the consumer goes down? Right, consumer goes down. Just read from the latest. If the consumer group, okay, it will rebalance. Okay, so consumer, if this one is consumer is done and the Kafka inside, it will automatically to choose the right consumer to let the consume some information. And based on the offset, right? Before that, we have the offset stored in the Kafka. So it's a way to keep continue. Okay, so arrow for the retries, producer retries. Producer retries is that we can do some sets, right? Current here consumer, we want to retry it a few times to get the information. If not fair or failing, right? We will move to the specific message in this which is called dead letter Q. I think the full name is that topic, to make sure it can store the message which will not consume. If the developer want to see what happened, they can find the message in this one. And performance optimize. So batches message in the producer, right? You can set some here, configure something, and also in the here you can compression the message or something. You can do that. So there's two ways to solve this problem. It is called retention. How to pronounce this word?
Retention.
Retention. Yeah, retention policy means the message will not delete. It will store in the Kafka. And for the Kafka, is normally to default setting. The message will store at 7 days, and then it will remove it. Another is here the storage just 1 GTB, 1 GB when you start, and the purchase based on size. Yeah, this is Kafka. So let's back up to the overview about the Kafka design here. This one is more clear here. Right, we have producer and send through the producer API to send in the message to the different broker. And the different broker, they will have the different partitions based on different topic. You can send the message in that, and during the topic there has a leader managed by the zone keeper to pick up the leader. That the leader is to get the message immediately, and the follower will sync up from the leaders. And then for the consumer part, based on the consumer group, it will subscribe for the specific topic, like topic A, and consumers A will consume a message from the partitions 1, and then do the message consume. And also consumer, in the same consumer, right? It's not in the same group consumer. The consumer 1 and consumer 2 cannot consume the same partition. They have to be consumed differently. So it's very common question during the technology part. Thank you so much.